Okay, this is understanding the graph of a quadratic. So if I have the graph of my quadratic function, I should be able to determine a lot of things. All right, first of all, I should be able to determine what the leading coefficient sign is, whether it's positive or negative. I should be able to determine its vertex, the axis of symmetry, and I can tell where the function's increasing and decreasing, and the domain and range. All right, so we're going to do that for this first application. All right, so the first thing, it opens down, right? So it's opening down, which means the leading coefficient, which is that a value on the square term, right? A on the square term is negative, right? It's negative. So that's the first thing. I know it opens down. Then we can look at the graph and see what its vertex is, right? And so the vertex is the point where x is -2, right? X is my -2, y is 5, right? So -2, 5. All right. The axis of symmetry, right, goes through the vertex, all right? And so I drew it as I'll do a dotted line instead of a highlighted. All right, so I'm going to do a dotted line. So the axis of symmetry is this dotted red line. Draw a straight line. Alright, so the axis of symmetry is always a vertical line. Through the vertex. Which means it's a line x equals, right? Vertical is x equals. Well, it goes to the vertex -2, 5, and so that's the vertical line x equals -2. Right, that's the axis of symmetry. Alright, so I know the vertex -2, 5. I know the axis of symmetry is the x value. It goes through the x value of the vertex, which was -2. I also know where it's increasing, where it's decreasing, right? On this side, it's increasing. It stops at the vertex, and then on the other side of the vertex, it's decreasing. Alright, so where is it increasing and decreasing? Well, it increases from -infinity up to the vertex, it's the x value, so up to the axis of symmetry, which is -2. Right, or again, using the set notation, when x is less than -2, increases. It decreases on the other side of the vertex, right? On this side, from -2 to infinity, it's decreasing. So on the other side of the axis of symmetry, from 2 to infinity, it's decreasing, or when x is greater than, -2 to infinity, greater than -2, right? That's where it's increasing, where it's decreasing. I didn't say it or ask it, but the vertex would be a max. This would be a max, right? And then the last thing was I was asking for increase, decrease, and then the domain and range. Alright, so the domain for quadratics is all real numbers. Alright, I can plug anything I want into a quadratic, so -infinity to infinity would be the interval notation. The range, however, depends on where the vertex is, right? Is a maximum value or a minimum value, right? It's my y values. And so my range has to do with my y values, right? And so this would be the maximum function value, right? It doesn't go beyond 5. 5 is the biggest y value in my entire function. And then after that, it shoots off down to -infinity on both sides of the 5, right? Shooting off to -infinity. And so the range goes from 5 to -infinity. That's my y values, right? They range between 5 and -infinity. And so my range, -5, we'll pop it right the other way, -infinity up to and -5 is a part of my function, right? The vertex exists at 2, not -5, to +5, right? To +5. My function exists from -infinity to +5, and it includes +5, so we need a bracket there. Right, if we were using set notation, it'd be all my y values such that y is less than or equal to 5. Right? That would be my set notation. I want every y value existing from 5 to negative infinity. And we're going to do another example of this, but this time we're not going to be given the graph. We're going to have to use the graphing calculator, right? You can graph these functions on the graphing calculator. So we've got our, again, use the graph of the quadratic function, determine the same. So we're going to do the same thing, but this time we're given the function and we have to graph it. All right, now before we get to the graph, we can actually determine the first part. All right, the leading coefficient here is 1, right? A is 1 when it's just x squared, which that means it's greater than 0, so my leading coefficient is positive. Which means my graph should open up when I go to graph it. Alright, so we're going to do that because we're going to find the vertex, and we're going to use everything else as based on the fact if I could find my vertex. Alright, so we can do that on the calculator. Because again, I know my vertex is going to be a minimum. Alright, so go to the graphing calculator, clear out what I have in there. So clear. Alright, type in my function, which was x squared minus 6x plus 12. I'm going to start with a standard window. I may still have to go back. I'm fine. Alright, I just make sure I can see my vertex. Basically, that's what I have to be able to see. So I start with a standard window. In this case, if I couldn't find my vertex, I would have to go to my table to figure out, how big do I need my window to go. Alright, well that's it. So my vertex is here at the bottom, and remember it's a minimum. Where we go find the minimum on the calculator? It's under the second trace key. Right? We're doing calculations on my graph, and so you have to hit second trace, and then you've got a whole list of things you can do on your graph. We want to find the minimum, right? The vertex is the minimum in this case, so I pick 3. Then the calculator will ask you some stuff. It'll ask you to go to the left. But basically, there's a program it runs through. And it goes back and forth between the two values I picked as my left and my right bound until it finds the smallest one. So I need to make sure that I am to the left of my minimum. And then I scroll over and make sure I'm to the right of my minimum. And then it's way to the right, but that's okay. Then it asks you to guess, and the guess just means it'll make the calculator solve it faster. So the closer you are, the faster it'll be able to find it. So there's my guess. Enter, and then it finds it. So my minimum is at 3,3. And again, it's going back and forth until it hits the smallest. And so sometimes it is off a little bit. It is exactly at 3,3. Alright, so again, the minimum is at 3,3 would be my vertex, which is a minimum. Alright, so just be aware of that. The calculator is flawed, but that would make sense if it's 3 with a whole bunch of zeros and then a 9. We'd round that. The significant place to round that would be 3. 3 would be the right answer, not 3.000009. Same thing if I had a 3.99999, I'd round it to 4. Alright, so just make sure you're aware of the calculator's not perfect. Okay, so you do have to use a little logic to figure out, alright, my answer would make sense that it's 3. And if you want to test it out, you can always go second trace, value. Remember, we could plug a value in. We'll plug 3 in. You get 3 out. Alright, so 3,3 is the vertex there. Alright, so my vertex, my minimum is... So again, if I've got my graph, there's my minimum value at 3,3. Which then I can find my axes of symmetry, right? My axis of symmetry. Well, that would be the line that goes through, right? My vertical line that goes through my vertex. Well, my x value, right? X equals is a vertical line. My x value is 3, and so the axis of symmetry is the line x equals 3. Alright, then where is it? So equations, make sure I'm leading coefficient, find its vertex, its axis of symmetry. Where is it increasing and decreasing? Alright, so my function, f of x, is increasing. Well, on this piece, right? So from 3 to infinity, it's increasing. So from 3 to infinity, we don't include the 3. 3 is a stopping point. It's where it's switching directions. So it's increasing on the piece from 3 to infinity. F of x is decreasing from negative infinity to 3. So right on this side I'm on decreasing. So from negative infinity up to that axis of symmetry 3. Alright, so that's where it decreases. Domain for quadratics is always all reals. So from negative infinity to positive infinity. Range, though, is not, because I have a low value or a high value. In this case, I have a low value. My low value happens to also be 3. I mean, it has to do with the y value, right? And so my low value here was the y value 3, and then it shoots up to infinity on both sides of that. And so 3 is the lowest value my function hits. Right? So the lowest y value is 3, and then it shoots up to positive on each side of 3. And so the range is 3 to infinity. Including 3, it exists at 3, or if I use the other notation, all my y values, my function values, for y, are greater than or equal to 3. Right? They're all bigger than or the same as 3, right? 3 is its smallest, and then on both sides of 3, it gets bigger. Right? Shooting off to infinity. Alright, so that's kind of a bunch of information that I can determine based on the graph of the function. So we'll